Hi, and welcome to the Introduction to the Cookbook of IIIF Recipes Lightning Talk at the IIIF Conference 2021. I'm Kirkpatrick. I'm tech lead for special collections at the Yale University Library. I'll let my co-presenters introduce themselves as they come on. But we just wanted to give a brief overview of things like, what is the IIIF Cookbook anyway? So you guys have a sense of what we're doing here. So for the cookbook, if you think of the spec as the building blocks for interoperable representations, the cookbook consists of examples of these representations, particularly as IIIF manifests. The point is to serve as a reference and to encourage learning by giving lots of these examples, more than the spec can, looking at publishers and developers and others. Real quick, I'll look at the cookbook website. We've got a long table of contents, both of what we're hoping to do and what we've already done linked, linking out both to the presentation spec as well, to the issues repository in GitHub, where these recipes start and often get discussed for how they're going to become the recipes eventually, and then out to the cookbook process. We hope you'll consider working with us, and that process can be of a lot of help there. A little more detail on those recipes. We feel like we've done pretty well in some areas, have more to go in others. We've done just over 25 in the last 12 months, best right now in the basics, and have some great discussions in the group and the TRC, more about TRC later, about transcriptions and captions, and definitely have a ways to go on real world complex objects. They're some of the most interesting and useful, but also pretty difficult. For our audience, fundamentally, we're looking at publishers, we're looking at researchers, including students and teachers, looking at developers of workflows and clients, and yes, even managers and administrators. So I'll pass it off to Dawn.
Thank you, Trip, for that wonderful and concise intro to the cookbook. I'm Dawn Childress, and I'm the librarian for digital collections and scholarship in UCLA's digital library program. I'm also one of the cookbook authors, and I'm going to walk us through the anatomy of a recipe. So all recipes follow the same paradigm, starting with a clear use case that focuses on a desired end result. The use case is followed by an implementation note and any restrictions. And finally, there's a description of the example object used to illustrate the use case and a full functional manifest. So we try to keep recipes as simple as possible, excluding any functionality that isn't required for the use case, even if it's something pretty standard. That way we can isolate just the important bits, making it more clear what is required. So in this recipe, the use case involves representing objects that have metadata values in more than one language. The implementation note pulls out the relevant parts of the spec that are needed to correctly format that metadata. Not all recipes have restrictions, but in this case, there were two. And the example section tells us what our sample object is and provides notes on what you might see in the manifest just below it. The manifest is embedded directly into the recipe with line highlighting to draw out the relevant lines. And just above the manifest, you can find links to view the JSON and also to open the manifest in a viewer. So once a recipe author has finished the recipe, it's first reviewed by the cookbook authors group, and then it goes to the cookbook editors for review. And once a recipe is ready for voting, a TRC issue is created. And then at the next TRC meeting, the recipe is presented and discussed, and voting begins and is open for 2 weeks. Some folks also leave comments in the issue with suggestions or recommendations. And then finally, the votes are tallied. The recipe is either approved with edits, or sent back for a more substantial revision. And in this case, all were in favor. So now I'll turn it over to Bryan.
Thank you, Dawn, and thank you for showing us the anatomy of a recipe and how they get through the review process. So the point of going through all of that and producing a recipe is so that it exists as a guide to solve a use case. So how do you know that you're ready to start looking at recipes? You might have a question as specific as, I know this is how I'm going to have a IIIF resource, but what does that actually look like when it's encoded? Or I have this real world object, like a book. How can I represent that through the IIIF resource types? Or even questions about media, putting multiple types of media together with one thing. So we have examples of what a manifest looks like, and you can see at the top of our cookbook page, different simple sort of manifests you could go through to look for examples. And we have examples of real world objects that have already been represented. And those are things you'll recognize, like books or movies or newspapers, scrolls, special collections, paintings, spectral RTI images, or even something that has spatial information like a map. So it's a regular occurrence that we go through this and people realize how useful the cookbook can be. And then they go and they have something like, oh, I just love the Beatles. How can I represent their discography? And they go and look and see examples around that are sort of lacking. Well, that doesn't mean you can't do that. You definitely can. All cookbooks start empty. What we're looking for is an idea and a plan, followed by some kind of trial and error that leads to positive feedback and replicable success. And we're waiting for you to do that. So hopefully you've learned enough today to know about how to get started. Here's where to go to maybe submit an issue for a recipe. And if you're interested in knowing more, we have another session later, IIIF Cookbook and Open Conversation, happening on Wednesday, June 23rd. Thanks, everyone.
Hi, I'm Courtney McClellan. I'm an artist and an educator and the 2021 Innovator in Residence at the Library of Congress. I'm here to share a bit about my Innovator in Residence project, Speculative Annotation. Speculative Annotation is a dynamic website and public art project. The tool presents a unique mini collection of free-to-use items from the Library of Congress for students, teachers, and users of all ages to annotate through captions, drawings, and other types of mark making. Working with library curators and students and teachers in the classroom, we developed speculative annotation to provide a way for students to speak back to history. Speculative annotation connects items from the past with the day-to-day experience of users. It was made with a K-12 audience in mind, with the hope that primary sources from the library's collection will be used by educators. The items were shared with contextual aids, including curator annotations and links to additional resources for further research on the library's website. What you're looking at now is a simple annotation created on speculative annotation. And after creating one, you can share it, you can post it to social media as a way to continue the conversation. And now I'm going to turn it over to our developer, Adam Arling.
Yeah, my name is Adam Arling. I'm a UI developer at Northwestern University Libraries. The application is written using the React JavaScript library. And it's basically just a collection of UI components which lay out a workspace, interactive tools, and various user controls. So this is the kind of the base layer of the app where users can view metadata about a work, save incremental annotations, and select other works to interact with. Images are rendered using the OpenSeaDragon viewer package, which acts as the second layer of the app. OpenSeaDragon provides deep zoom functionality and a whole event system handy for interactivity. The app is set up to either import local images, or we could feed OpenSeaDragon images hosted on Library of Congress's IIIF image server or your own IIIF image server. The third layer of that application is the annotation layer. So annotations on the screen, such as drawing, typing text, applying stamps, or drawing shapes, are all handled by a JavaScript library called Fabric.js. And interacting directly with web browser's Canvas API can become quite cumbersome doing anything beyond simple interactions. So Fabric.js provides a helpful layer of abstraction for common Canvas-related interactions. For example, painting a line across the screen with the mouse or your finger. Fabric makes available a full suite of prototype objects or classes, which speculative annotation uses heavily to support the user tools. Since speculative annotation is a single-page application, all the app's data is fed by either local files or data retrieved from public APIs. Library of Congress hosted IIIF manifests supply half the metadata describing each Library of Congress work, and metadata is further supplemented by IIIF 3.0 spec manifests, which are local to the application itself. Speculative annotation uses a single top-level collection type manifest, which contains data relevant to the application itself. And then child item level IIIF manifests detail each of the application's Library of Congress works. So what's different or unique about this application? Aside from the Fabric.js interactivity, the UI is, to a certain extent, driven by IIIF structured content. So theoretically, if your organization or institution had collection or item level information saved in publicly available IIIF manifests, you could configure speculative annotation to point at your data, your IIIF manifests, instead of the Library of Congress's. And since speculative annotation application is written to consume data from a standard spec, like IIIF, instead of just an ad hoc data model, it could serve as an example to really open up the doors in creating reusable UI components. So what's also unique about this application is its potential for sharing editable user annotations if backend services were written to extend the app into the future. The annotations themselves, although visual in nature, can all be entirely represented by JSON data structures. The Fabric.js library can both create and consume these data structures. So say I wanted to share an annotation with my friend living across the world. So now my friend could say visit the app, the client UI parses the updated manifest, grabs my JSON annotations and translates these back into cool shapes and colors that they can see. So we can collaborate, we can work on revisions or come up with unimagined workflows. I think basically the IIIF structure is a reliable way for which apps, especially UI apps, can look for data in order to share.
Hello, my name is Madison Goforth. My pronouns are she, her, and I am the Collection System Specialist at the Princeton University Art Museum. Today in my lightning talk, I'm going to briefly discuss how we use IIIF for teaching at the museum, and specifically how using IIIF helped us more easily transition to virtual teaching last March 2020 due to the COVID-19 pandemic. To begin, I wanted to briefly introduce the Art Museum. The Princeton Art Museum is a university museum, and its mission is to educate, challenge, and inspire the students of Princeton University and members of a diverse local, national, and international public through exposure to the world of art. So as an academic museum, teaching is really at the core of everything we do. To put that into perspective, I have a few stats about the museum's teaching engagement on campus. In recent years, the museum has on average had about 150 class sessions per semester, including both in-gallery teaching with objects currently on view, as well as classes in our precept rooms with requested objects. Right before the pandemic in fall 2019, that number was 193 class sessions for the semester. And then during the following spring semester, teaching continued with 66 classes in person and then 70 virtual classes after closing. The courses at the Art Museum are from a wide variety of departments and concentrations on campus. We've reached over 50 departments so far, including everything from art and archaeology to ecology and evolutionary biology and many more. Next, before I talk about what we did to transition to virtual teaching last spring, I wanted to talk a bit about where we already were and what existing infrastructure was in place. So on the technical side, we had already implemented IIIF for our collections catalog. And as you can see by this screen capture, for any object in the collections catalog, you can go to the object page, you can click on the image, and you can open the image up in the Mirador viewer. We also have an API in place that we use to deliver our object data, which made it easier to pull collections data into new manifests. And then on the more human workflow side, one key process already in place was that we were already doing really robust tracking of all the objects used by courses by our collections management staff. We use TMS as our collections management system and track courses and related objects in object packages. So this tracking was already in place because it helped facilitate physical object movement and course proctoring when teaching in person. And without it, we couldn't have built the virtual teaching resources without having these sets already tracked. So here's an example of what that looks like. In the Mirador viewer, you can navigate through different objects in the set, can view some basic metadata, and then you can view the objects in gallery mode, go to a specific object for that course, and then open up another object in the course in order to compare them and view them together. So more specifically, we did the following. We implemented IIIF for courses by building new manifests based off of the sets of objects that we were already tracking. We also created a new landing page for our website with the course listings and specific links to the related viewer for each course. In addition, since we already had these course sets implemented, besides using the groupings in the Mirador viewer, we also created other digital resources based on the sets, including downloadable PowerPoint presentations and zip files of images, recognizing that different courses, professors, students have different needs. So all of these resources based on course sets are updated nightly by a series of Python scripts that create these resources. And right away, we got some great feedback that folks were really happy with the resources and the Mirador viewer experience in particular. But we also had some improvements, the biggest being that we transitioned to 3.0 and decided to represent courses as collections so that a course manifest would reference all of the existing object manifests. And that allowed us to include multiple images per object instead of just one, which was particularly important for teaching with our 3D objects, as you can imagine. Here you see an example of what that looks like. You've got the collection with the links to all the objects. You can open one up, view multiple images for that object, go back to the collection, open another object, and again, view the various images. As we showed earlier, you can compare that with another object from this course in order to view these objects, including, again, their multiple images together. So where we are now, we are getting ready to release 3.0 and courses as collections next month. We've in general got some great feedback from our curators and our education department on how useful it is to have these course sets in the Mirador viewer. In terms of usage from last March 2020 to today, which I am recording this at the end of May 2021, we've had about 1,300 distinct users of the Mirador for the teaching sets specifically, and about 6,000 overall sessions. And finally, I would say that a great outcome of the Mirador course sets is that they've been a good advertisement in general for our implementation of IIIF overall. So I think more people know now that they can access these high-res zoomable images from our online collections catalog. That's all I have. Thank you so much. Please reach out with any questions, comments, or feedback. My email is mgoforth@princeton.edu. Thank you.
Hey, everyone. It's great to be here at the IIIF conference, and it's great to see so many friends and colleagues from around the world, even if it is just as tiny rectangles of joy. My name's David Newbury, and I'm the head of software at the Getty. Getty as an organization does some really cool things with IIIF, but today I'm excited to show off a personal project I've been working on. One day I was going through the collections at Getty, and I came across a stereograph photo. They're the original 3D technology, photos taken with two cameras side by side. The photos are offset, just like your eyes, and if you view one image with one eye and the other with the other, your brain will stitch them together into a 3D view. Back when stereographs were popular, people viewed them with a special viewer called a stereoscope. You might remember Viewmaster toys. A little known fact about me is that I used to own an antique store, and one of my favorite things to do on slow days was to go through the boxes of old stereographs and Viewmaster discs I had lying around. Seeing that stereograph in our collection reminded me of an amazing digital project from over 10 years ago, Stereogrammer from the New York Public Library Labs. Use Flickr and their collections to allow you to turn stereograph images into flickering GIFs. The project was definitely an inspiration to me back in 2011, and seeing the photos in the Getty's collection made me think about how cool it would be to do that using IIIF images instead. It turns out that the past year wasn't an awful time to work on projects that involve staring into screens and never leaving the house. So I built out a first version of a IIIF-powered stereograph viewer. This system allows you to paste in a IIIF manifest from any collection that provides them. Here, I'm using an image from the Getty's collection. Images were usually printed onto cards, and each card is different, so you need to identify the region of the card that's for each eye. You can do this by drawing a box around one of the eyes and by clicking and dragging. You can then position the other eye by dragging the slider back and forth like so. Sometimes the back of the card is the first image, or the manifest has multiple stereographs in it, Thumbnails on the bottom here allow you to choose which of the images is the stereograph of choice. Once you've got your boxes drawn and positioned, you can use a couple of techniques to see them. Sadly, I don't have a good way to print my own ViewMaster discs, but we can show the images side by side, letting you view them in 3D Magic Eye style by crossing your eyes. You can also show them using the technique I first saw on Stereogranimator, by flickering back and forth between the two images. It's such a fun way to view these. As you can see on the site, I've also included an option to download these images as animated GIFs. Of course, this isn't limited to just the Getty's collection. Other collections of stereographs can be shown here as well. For example, here's a great image from the National Museum of African American History and Culture at the Smithsonian. It really shows off how well this flickering technique can work. We can also look at this great picture from the Tennessee Virtual Archive. It's scorchingly hot here today, and I love the idea of climbing a mountain. Again, I haven't downloaded these images at all. All I'm doing is using the IIIF manifest to pull their information into this viewer. Well, that's not completely true, and I apologize in advance for the sudden deep dive into IIIF technical nerdery. But if I can't do that here, where else would I do it? For those who don't spend their time reading draft specs, I'll come back to 3D photos, I promise. As many of you know, and if you didn't know, there are great presentations later in this conference. One new draft spec in development from the editors and community is called Content State. It's a spec that allows us to share not just a link to the manifest, but to a particular region of a manifest, to a particular canvas, or even to a region of a canvas. And you can see why this is so exciting to me, to link it to multiple regions of the same canvas. What this means is we can take the rectangles of content that define those two stereo images and encode them as annotations onto the canvas linked to the manifest. And then we can, following the spec, shrink that JSON down, base64 URL encode it, and add it as a IIIF content parameter to the URL. Okay, that's a lot of nerd words in a row. To go back up a layer, what this means is we can generate a bookmark to this page with those crops already set and have those crops tied to the manifest, not to any data stored on this site. And we can do that in a standard compliant way, which means you have a way to identify those annotations in another system, and you can send them to this site or others and have those crops set automatically. It also means there's no backend of the site at all. Everything's done in the browser. It's just a very, very specific IIIF viewer. I wouldn't recommend reading a book in it, but you could. Oh, and one more thing, which is my favorite feature of the project, and also the absolutely worst thing to demo that I've ever built in my entire career. You may have noticed at the bottom, there was actually a third way that you can preview these stereograms in virtual reality. Using A-Frame, I built a WebXR viewer that pulls these stereographs into a virtual gallery where you can see the images that they were originally intended while wearing a ridiculous device strapped to your face. The problem, of course, is that I can't show it to you. You're not wearing VR goggles. So all you see is this photo in a frame. You'll have to trust me that this is really, really cool. Or if you've got something with VR capability, you could try it out yourself. It's just a website. Any device should work. There's nothing to download. Check it out. You can get to the site at stereograph.davidnewbury.com. There are hundreds of thousands of stereographs and collections all around the world, and with IIIF, we can make them all accessible in new ways. Thank you so much.
So I'm going to be talking about IIIF and machine learning, in particular looking at how IIIF can make computer vision methods much more accessible. So starting with computer vision itself, there's been massive improvements in the performance of computer vision systems from the early days of these postcode recognizer systems. And a lot of these problems have become more accessible through improved techniques for transfer learning and the reduction in data set required. And this has got to the point where this MNIST dataset for recognizing handwritten digits is now often introduced as a kind of tutorial exercise. This has got to the point where a Raspberry Pi can perform the same OCR as these massive machines were performing just a few decades ago. So what does this have to do with IIIF? In the rest of the talk, I'm going to be looking at the Newspaper Navigator dataset and how IIIF can support working with this collection. The Newspaper Navigator dataset is a collection of visual content extracted from historic newspapers, and it was produced by the Library of Congress Labs and Benjamin Lee. And in particular, I'm going to be looking at how we can explore the visual content in advertisements in those newspapers, and particularly how IIIF can support us in doing that. One of the first challenges of working with this data set is the sheer scale, and particularly over time this grows massively, and this poses challenges for working with this collection with limited resources. So now we'll turn to how IIIF can help us in developing tools to overcome some of these challenges. So NN Anno is a modest collection of tools that is aimed at making it easier to work with this newspaper navigator data, and this uses IIIF throughout to support many of the functionalities. So obviously, if we want to create a machine learning model to work with this data, we have to create some initial annotations to train our model, and IIIF could support us in doing this. In particular, we can use the bounding boxes provided as part of the newspaper navigator dataset to create URLs that we then use in this Label Studio software to produce annotations that we'll later use to train our model. IIIF is really powerful here because it allows us also to set things like the size and the quality of the image and annotate in a quite easy manner using these existing machine learning tools which already support annotating images from URLs. So in particular, what's useful here is being able to pass the size of the image that we want to display when we're annotating these images, and this provides us an easy way to control what size to annotate. Once we have these annotations, we can train a computer vision model. And because of the developments in transfer learning and these new approaches to training models, we can very quickly train a model that performs pretty well with relatively few annotations required. Now at this point, we're using images that have been downloaded locally to the system where the model training is happening. And we could use IIIF directly for this as input, but it's probably not a particularly effective use in this case. But what we can do is use IIIF to download the images in the required size that we need for our model training. And this obviously saves a lot of time in pre-processing data to get it into a consistent format that a lot of computer vision models expect. So once we have our trained model, we turn to inference, and IIIF is used extensively here. And in this particular case, because we're working with such a large collection, because we're more interested in extracting a representative sample and generating metadata about the types of images in that sample, we don't run predictions across the entire collection, but instead use IIIF as a way of accessing a subset of the newspaper navigator dataset. So here again, IIIF is really useful, particularly because we can extract the images in the exact size that our model expects, and this also reduces the amount of data that needs to be sent across the network to our model and speeds up the inference process. So on the NN Anno repository, there's a fuller example that looks at this case study of exploring the history of advertising in this collection and how IIIF can support us in doing that work at various stages in the pipeline. So coming back to this original question, IIIF provides a lot of support across all stages of the pipeline. Being able to request images in various sizes required for annotating training data, and then provide the ability to run inference on large collections with relatively few resources. It's all really powerful. There's also a lot of potential in the future for IIIF to target existing machine learning tools and software to further enhance the support for those tools to support IIIF, and hopefully that will open up machine learning and particularly computer vision to even more people.
Hi there, my name's Pete Morris. I'm one of the software developers at the University of Manchester Library. And I'm here today to talk a little bit how we use IIIF metadata to enhance the homepage of our Manchester Digital Collections website. So we launched our Manchester Digital Collections website in January 2020. This was a collaboration between the University of Manchester and the University of Cambridge. And we did this to expose some of our great special collections that we have to the world. We wanted to make a website where people can access those digitally without having to be physically present. And this was a great success, but the homepage that we created was relatively static. We'd have a list of the collections that we had. It was quite artful, but it wasn't very dynamic. It didn't update itself. And we felt that we could improve upon that. And we decided we'd do that by looking at the IIIF metadata and seeing if we could use that to actually populate the homepage itself and produce some slightly more dynamic content. And I'm going to talk about some of the issues we encountered and some of the success stories we had with that. But one of the things we discovered early on is that the metadata that we were obtaining over IIIF from the CUDL system that powers this website was simultaneously in some ways too restrictive and in other ways too verbose. So to give an example, one of the collection feeds that we have has information about the type that it's a collection, it has information about the label for it, the title of it, so to speak, and it has the information about where you can get more IIIF data from it. But that's really it. And we needed things like when the collection was released, we needed thumbnail information, all of that kind of stuff, and this wasn't natively present in the data. On the opposite direction, some of our collections, here's an example, this is one of our Bible illustrations, we have a item here which has 526 pages, and for each of those pages we have a little metadata entry. Now that's a lot of data coming down the wire. It's about 147k in total, and we don't need all of that. All we need is a summary of how many pages there are in the book, for example. So our solution to this was to see if we could combine this metadata with our own metadata and parse it in a middleware format. So we wrote a little application to do this in Node.js, which polls for IIIF feeds on various intervals. Some it does per hour, some it does per 24 hour. It really depends on how often we feel it needs to be updated. And it stores the results of those polls in its own little database that it has. And this means that rather than the web browser talking to IIIF API directly, where there may be too much or too little data, what it does is the web browser talks to our middleware, and it's our middleware that then decides how much or how little data we're going to expose as a result of that. And this is useful because it means that we can append it with other information that's useful for us. So to give an example here, we have 40 items in this top collection. This is the name of it, Magic Monsters Macabre. How many pages we've got in it. We've got when it was released, that's really key for us. So that's a thumbnail within our system and the original title that it was. And we're able to do this now for each of our collections and pull this from our middleware. And the result of that, I mentioned the release date, which is really important for us. Well, that means, for example, that we're able to put together our latest collections section. So these 4 items here are the latest ones that we'd released at a particular point in time. And we're able to show that, and that updates automatically, so we don't have to actually change those collections. Each time you go to the website, you'll always see the latest collections as those 4 items that we've released. And that's an example of the dynamic content that we're using. Another thing that we were able to do is we thought, well, if we can poll this information, perhaps we can actually add to it ourselves. And so we started thinking about different things we could add to the metadata, since it was going to be sourced from the same middleware. And one of the ideas we came up with was to do a bit of artificial intelligence work, which we'd been playing around with, and see if we could write an AI application which would identify particularly colourful images. And so we trained it up on a large number of images which we subjectively felt looked quite colourful, and similarly a lot of images that we subjectively felt didn't look very colourful. And we trained the AI algorithm around that and then allowed that to score all of the items and all of the pages in our collections and returned that with the metadata as well. And that allows us to actually have a little section here where the AI will try and identify a colourful thing for you to look at, and then you can vote upon that as to whether you agree with what it came up with, because it's all very subjective. And your voting is stored back in the database. We can expose that through the middleware again. The process goes round and round, and this means that each time you go to the page, you'll see other people's thoughts on the matters, their votes, you'll get the latest collections, which are the most popular, all of this kind of stuff, which makes for a much more dynamic interaction. So going forward with this, what we might try and do is we might try and merge the IIIF and middleware together into a single feed. Now that would be quite useful, because at the moment we've got two feeds that we're consuming, and it's okay for our website, but it would be quite nice if we could merge the two together. So we could enhance the IIIF feed and indeed restrict back when we need, all from the same API endpoint calls. So that's something we may look at doing in the future. Thank you very much for listening. I hope you enjoyed the presentation.
Hi everyone, my name is Ben Bakelaar. I'm a digital architect, and today I wanted to share with you some learnings from the Metascripta project that I've been working on for the past 2 years relating to converting TIFFs to JPEG 2000. So just to give you a quick overview, what we're talking about, our current state of the project, is that we are running in the cloud on Amazon using Cantaloupe Image Server and the Kakadu compression codec, and the files, the JPEG 2000 files, are stored in an S3 bucket. And what this powers is our discovery layer, where once you load an item, you can view it in Mirador. So at the beginning of the project, we were looking at these external drives full of images. In this case, the most recently processed batch was 2 terabytes of microfilm scans, about 100,000 files. And at the beginning, we had received some advice from an institutional IT resource who was very smart and very cloud-centric, that, well, you can just upload the files to S3 and we'll set them up to auto-convert with a Lambda function. I don't know if anybody actually has that working yet, but it's certainly not something you can do with Kakadu as far as we know. But we made some assumptions. We assumed that since we were running our servers in the cloud, we should also run our image processing in the cloud. And we started off loading one roll at a time and tried to create a multi-person workflow where people could process them, and it really just didn't quite work out the way we thought. We thought we could set it and forget it, but that's not true. And in particular, I wanted to highlight for anybody else who's considering where to do your image processing, speed differences. So on the cloud, in our Cantaloupe server as it's currently configured, it takes 22 seconds to convert a single folder of these TIFFs to JPEG 2000. The equivalent time on my local iMac, which is a 2017 model, is 8 seconds, even if I'm running it directly off the external drive and not loading the file onto the local SSD. So our family that we're using inside AWS is the T3A family, and we're currently on medium, right? So you might think, well, let's just boost it up temporarily so that we can process things. So we've doubled our CPU and our RAM, and still local's faster. We're getting 11 seconds on the cloud versus 8 seconds locally. So let's convert all the way up, well, one more layer to X large. And at this point, with 8 CPUs and 32 gigs of RAM, we are outcompeting my local computer that has essentially 4 CPUs and 8 gigabytes of RAM. But it has a graphics card, which I think is the key difference with cloud resources. So you might think, well, that's great. You figured it out and you can run your image processing off of that. But beware. If you were to leave that server on for 1 month, for 720 hours, remember Amazon is hourly metering, just like a utility, and you provisioned your 2 terabytes of storage to kind of hold the converted files, that can be over $1,000 a month. Maybe even $45 a day. Now, there's many ways to optimize the cloud, but the point is if you're not very experienced with the cloud You're not totally sure where your files are, if they're going to remain there when you turn your server off. This could be a problem. It's very easy to accidentally leave your resources on and the bill keeps going up. So the main point I wanted to make in this lightning talk is that local hardware is still viable. This is essentially my 2017 Mac, currently $800, and that's producing image conversions faster than a very pricey cloud server. So to kind of give a very quick summary for this lightning talk, whether you're processing 100,000 files or 500,000 or millions, it's not a one-time set it and forget it task. Maybe there are certain institutions and enterprises which have the workflow established, but if you're an independent project like Metascripta, starting from scratch, you may not have those experiences. And after the conversion, there's other steps that need to happen as far as inventory, validation, error checking, uploading. So if some smart IT person tells you we'll just convert them, auto-convert it with the Lambda function, there's more to it than that. You don't need SSD. I thought that early on, but the external SATA speed is fine. You also don't need the cloud. If you don't know exactly what you're doing, assuming you need to use the cloud or that it will save you time and money may not be true. And simply buying an external storage drive and a mid-range iMac desktop or laptop will give you a dedicated platform that's very fast, and you don't have the concern of hourly metering. And so in total, I ran this 99,000 files in 28 hours. And of course, my scripting is something I don't have time to get into. So thank you very much. And if you'd like to see more slides in this presentation, go to this URL.
Hello, my name is Julien and Raemy, and along with Lukas Rosenthaler, we made this lightning talk about SIPI, a IIIF Image API 3 server that is maintained by the Data and Service Center for the Humanities, or DASH, in Basel, Switzerland. SIPI stands for Simple Image Presentation Interface, and the early development of the software began in May 2016 at the Digital Humanities Lab of the University of Basel. SIPI has been supporting the IIIF Image API since the beginning. Versions 1 and 2 of the server are compatible with the Image API 2.1 and version 3 with the Image API 3. It has four main functionalities. Primarily, it serves as a IIIF Image API server. It is also an ordinary web server, can convert different image formats, and has some database integration capabilities. It is written in C++, is level 2 compliant IIIF Image API 3, works on Linux and macOS, and for encoding and decoding JPEG 2000 images, it relies on Kakadu. But otherwise, all the other components of the software are open source and available on GitHub. It supports also multi-page PDFs in a IIIF Image API-like fashion. Here we can see SIPI in action. After making the software run, I am entering the appropriate URL, which is based by default on the file name. So first we see the info.json, and then the content with the Image API 3 parameters. So full, max, 0, default here, then in bitonal, grayscale, and so on. Different percentage, for example. So SIPI implements some backwards compatible non-standard extensions to the IIIF Image API, such as allowing to access the pages of a multi-page PDF in any format using the Image API syntax. The prerequisite is that the file is available in the repository in PDF, and only the identify section of the IIIF syntax has to be extended with a non-standard extension adding in @ character, followed by the number of the given page. SIPI was developed with long-term preservation in mind. All 5 format conversions try to preserve all metadata, EXIF, XMP, or IPTC, for instance. SIPI can embed important preservation data, such as a checksum of the pixel values, original file name, and so on in the file headers. SIPI can deal with and convert ICC color profiles based on the Little CMS library. It supports SSL, and also it embeds the scripting language Lua that allows a very flexible, highly customizable deployment that can be adapted to the environment SIPI is being used in. SIPI is also a normal web server that is able to deliver any kind of files. Using the Lua scripts and routing, RESTful interfaces may be implemented. For instance, image upload and conversions may be supported through HTML pages. SIPI doesn't yet support the IIIF presentation API, but since it is a web server, it can easily do that. Like here, easily serve those. Like here in this example of a version 3 manifest built for the purpose of a project called Participatory Knowledge Practices in Analog and Digital Image Archives that we do at the University of Basel, which will leverage IIIF. So here we see the example in Mirador. Image format conversions are also supported between TIFF, JPEG 2000, JPEG, PNG, and PDF, but with some limitation for that format. SIPI can be used either as standalone command line tool or in server mode using Lua. And again, SIPI preserves most embedded metadata and is preserving and converting ICC color profiles. SIPI has an integrated SQLite 3 database that can be used with special Lua extensions. Thus, SIPI can be used as a standalone media server with some extended functionalities. If you had to remember 2 things about SIPI, so first of all, that it is suitable for any cultural heritage institutions, either for dissemination purposes, but also for long-term preservation. It is also quite flexible and fast, thanks to the use of Lua scripts. In the future, we would like to implement some IIIF Presentation API 3 capabilities, so we may do that in the coming month. Also, the latest version only supports IIIF Image API 3, and we're looking into how we could have some backwards compatibility with a previous specification for the future releases of SIPI. Something that came into our radar is the support of JPEG XL, as it looks quite promising, and perhaps this could be achieved via VIPs. This could also have the potential to use SIPI without having to rely on a Kakadu license, making the software less dependent and completely open source. So stay tuned for more information, and do not hesitate to contact us if you have any questions or remarks. Thank you very much.
Hello and welcome. My name is Kevin Clarke, and I'm here with my colleague Mark Matney to introduce Jiiify Presentation, a new Java library to assist with the creation and manipulation of IIIF presentation manifests. Jiiify Presentation has actually been around for a while. It was started as a personal side project and really is a way for me to learn version 2 of the specification. UCLA, when we built our in-house manifest server Fester, also used it as the core of that service. And this worked really well until we got to the point where we needed to add our AV content into our IIIF infrastructure. For that, we needed features that were only available in version 3 of the specification. So we decided to extend Jiiify Presentation to support version 3 as well. Our goal with version 3 of Jiiify Presentation was to implement the full spec, not just the parts that we needed at the time. But at the same time, we wanted to keep it independent. We wanted it to be a library that could be used in a manifest server or be used in just one-off scripts. Having an additional programmer working with me on the project also allowed us to add new features that make working with presentation manifests much easier. For instance, the Mentor Factory. As you can see on line 2, a Mentor Factory takes a manifest and returns a mentor that can then create unique IDs for components of that manifest. So for instance, you see on line 3, we create a canvas and we pass the mentor to it. And on line 7, we create a painting annotation and we pass the mentor to it. The Minter will generate those IDs based on the manifest and the canvas on which they're found. The Minter class is actually an interface, and we have provided a default implementation, but if you'd like to write a different implementation and have the Minter factory return a different type of Minter, that's possible with Jiiify presentation. There are also the paint with and supplement with convenience methods. These methods save us the trouble of having to create the whole annotation page and annotation structure when we want to paint a content resource onto a canvas. With this, like you can see on line 6, you can have a canvas paint with a particular content resource, and that resource will be created within the annotation and the page annotation structure. It's important to note there are different semantics for this. You can pass the multiple content resources to a single paint with, which will add multiple resources to a single annotation, or you can call the paint with method multiple times, which will generate multiple annotations. Paint with also allows you to pass a media fragment selector so that you can constrain the passed content to a bounding box in space or time. Lastly is Jiiify presentation's ability to do media type sniffing. So we see here we're creating a video content resource that we're going to put into the body of an annotation. And in the JSON that's output, you'll see that there's a format supplied even though we didn't set format on the video object itself. Jiiify presentation will determine, based on the ID and the type of content resource that it is, what type of format is needed. In the cases where Jiiify can't do this, there's still an option to set the format explicitly so that you can control what type of format you want on your output JSON.
One benefit of implementing Jiiify presentation in Java is that it can be used with any language that has a JVM-based implementation, such as JRuby, Jython, Scala, Kotlin, Haskell, and many others. So, if you're more familiar with, say, Ruby syntax, you can write a Ruby program to run with JRuby, or you could spin up an interactive JRuby console to do rapid prototyping with Jiiify presentation line by line. Here's an example of Jiiify presentation's Ruby syntax to run with JRuby. The easiest way to use Jiiify presentation in a language other than Java is to install the so-called uberjar, which contains all of the library's third-party dependencies in one package and enables you to include the library in your project in one line. From there, you can include all the packages which contain the classes that you'd like to use, like manifest, canvas, and image content. And then just like the Java examples, instantiate those classes, compose your manifest or collection, and do further processing as you see fit. And in this example, we're simply outputting the serialized JSON LD to the console with puts. And note that in order for this code to work, it needs to be wrapped in a module, otherwise the include package statements will throw an error. Here's an example of Jiiify presentation's Python syntax to run with Jython. And this code will run pretty much as is, but there's one major difference with the Python syntax. And that is with the methods that take var_args parameters, like paintWidth and setCanvases, while in Java and Ruby it's permissible to pass a single object to them, like a single image or a single canvas, in Python you must pass a list. Finally, here is a list of web links for the project which you may be interested in checking out. First is a link to the project page on GitHub, and note that it is on the v3 branch, not the default branch of the repository. Second is a Gitbook with many of the IIIF cookbook recipes and several other examples not in the cookbook implemented using Jiiify presentation, mainly in the Java syntax, but also in the Python and Ruby syntaxes as well. And this is very much in a stage of active development still. Third is a link to the discussion board hosted on GitHub where you can ask questions about the project. And fourth is a link to the issues queue on GitHub where you can submit bug reports, suggest improvements, etc. So with that, we hope you find the project useful. We hope that you try it out, give it a spin, and let us know what you think.
Hello everybody, I'm Giovanni Benigni from the Technology Department of the Vatican Museums. It has been some time since I presented you our project of a new catalog in 2018 at the Discovery Workshop. And I'm very proud to say that today it is online and publicly available. After my participation at the workshop, I entered in touch with Richard and Lukas from Victoria and Albert Museum, starting a precious collaboration. They helped me more than once with technical information and support to create application based on our image server. And I don't really know what I've done for them in exchange, so I suppose I have adapted with both. Well, at any rate, they recently made an alignment test using our Raphael tapestries and their cartons images that I can say it is really interesting. It has really interesting outcomes, both at a technical and a curatorial level. Well, I don't want to say more about that, so I'll give the floor to Lukas, which will show you what he has done, with the hope that this will result in a closer collaboration between our institutions.
Thanks, Giovanni. It's been our pleasure working with you. I'm Lukas from the Victoria and Albert Museum, where we've also been integrating IIIF into our new collection site and using it in various ways to tell the story of the Renaissance cartoons by Raphael in our collection. Now, thanks to IIIF, this story could have a new chapter. Searching for Raphael in the Vatican collections, you can find the tapestries that Raphael's cartoons were made to produce originally 500 years ago. And because they're now both available through IIIF, anyone can reunite the cartoons with their tapestries once again. I've done that here in the Mirador viewer, very simply. This one is called The Miraculous Draft of Fishes, and Raphael's cartoon is coming through on the left directly from the V&A collections, and its corresponding tapestry that it was designed to produce being served directly on the right-hand side from the Vatican collections. And I've been exploring just how closely the tapestries and the cartoons might be reunited using our special viewer for comparing images in overlay. Here's the tapestry again, overlaid on top of its cartoon as it would have been physically during the process of transferring Raphael's design from cartoon to tapestry. And given the centuries the cartoons and tapestries have been hanging and the difference in materials, it's perhaps no wonder they no longer line up precisely. And indeed, the tapestries do appear to have stretched slightly in the vertical direction. You might notice I flipped the cartoon here horizontally, just as the tapestry makers did when transferring Raphael's design from cartoon to tapestry. I also rotated the tapestry very slightly, just by about ½ degree, to account for differences in photography. But crucially, I can still get each of the images being served directly from their respective institutions with the adjustments I need using the IIIF image API, and no need for creating derivative images. Similarly, I can position and scale each image as necessary to align them with each other. I can just show you quickly how I got all the image API parameters I needed using a simple tool we built for the purpose, which allows you to play with the position and scale of two images and find an alignment by eye. Again, the two images are stacked on top of each other, and with an opacity control, you can view them simultaneously, and just by dragging and zooming, you can try to get an alignment by eye. That looks reasonably good across all of the figureheads horizontally. I think that's about as good as I got it for the demo I just showed you, and it was as quick as that. And actually, it was the 2017 IIIF annual conference hosted by the Vatican that originally inspired us to build this tool as a demo. You can find a bit more about it at these URLs, and keep an eye on the IIIF channels for an upcoming webinar specifically on on image alignment as part of the IIIF towards the National Collections Research Project. And thanks for watching.